Hi, this is the first lesson in electricity. This lesson mainly focused on Edexcel, Cambridge, and International Baccalaureate syllabuses. Okay, the first simple topic in electricity is electric current. What is electric current? The rate of flow of charge. So, rate of flow of charge does not mean the charge should flow through a wire. The charge can flow anywhere, even through space or even through air. Say, for example, during lightning, charges flow through air, and that causes electric current. Due to that electric current, it produces electromagnet. Okay, you would have noticed during lightning sometimes your trip switch falls because the reason that electric current, that during the flow of charge it creates electromagnet. So when that electromagnetic field interacts with your trip switch or fuse, it falls down, is it? So electric current is defined by the following equation. That is, electric current is defined as rate of flow of charge, that is the amount of charge flown per second. So we can say charge flown divided by time taken. So the notation electric current denoted by capital I, charge capital Q, and time T. So from this I can get a first equation in electricity, Q equal IT. The unit of charge, it's coulomb denoted by capital C. Unit of time is second. So the unit of electric current according to this definition will be coulomb per second. Okay, so coulomb per second is called 1 ampere. So coulomb per second is defined as 1 ampere. Ampere is a base unit, you know that. Okay, so the unit of electric current according to the definition is coulomb per second, but it's defined as 1 ampere, and ampere is a base unit, and electric current is a base quantity. So we got the first equation in electricity, and we'll do a simple question based on this equation. Okay, so this is the first question. A simple question says current flown through a filament bulb is 2 amperes, and the bulb is used for 30 minutes. First part, find the amount of charge flown through the filament or bulb during this 30 minutes. So simply we can answer like this: Q equal IT. So the first part, Q equal I times T. We know the current, that is 2 amperes. The time should be in seconds, so 30 minutes into convert to seconds, 60. So solve it, you will get the answer 2 into 30 into 60. That will be 3600 coulomb. Okay, second part. Find the number of electrons flown through the filament during this time. We know that charge of an electron is negative 1.6 10 to the power minus 19 coulomb, but when we do calculations, we don't consider the sign. Okay, so how many electrons flown through the filament during this time? So how can we find it? This charge must be divided by charge of an electron, is it? So number of electrons flown, I call it as N. That is 3600 coulomb is the total charge flown during 30 minutes. One electron carries this amount of charge. So how many electrons flown? Divide by 1.6 into 10 to the power minus 19. So if you divide 3600 by 3600 divided by 1.6 into 10 to the power minus 19, that will be 2.25 10 to the power 22 electrons flown through the filament during the 30 minutes. Okay, so simple question. Okay, so we should know two different new words compared to IGCSE. First one is charge carrier density. Okay, when we think about a material, say for example copper or aluminum, a conductor or even a semiconductor, the current flow is due to the flow of delocalized electrons, that is due to the flow of free electrons. So the electrons in the last orbit of an atom can flow from one atom to another atom. So that is called free electron or delocalized electron. So the number of free electrons or number of delocalized electrons per unit volume of the material is defined as charge carrier density. Okay, so charge carrier density means the number of delocalized electrons or free electrons per unit volume. That unit volume must be considered in meter cube. So number of free electrons per meter cube is defined as charge carrier density, and it's normally denoted by symbol N. So the unit of charge carrier density is per meter cube. Say for example, when you think about a copper conductor, so it consists of almost 2 point, so the free electrons, delocalized electrons of, say for example, of semiconductor. For a semiconductor, we can say that is around 7 into 10 to the power 23 per meter cube. Anyway, just I gave an example. I didn't say the name of a semiconductor. So semiconductors have less number of delocalized electrons. We'll come to that point later. But the unit should be per meter cube. So N of a semiconductor, this much of free electrons per meter cube. Okay, so unit is per meter cube, number of free electrons per meter cube. Okay, next thing is drift speed. You know, when electrons, these delocalized electrons flow through a wire or material, they don't travel or they don't move on a straight line. They will have several collisions with the atomic planes, or they can have collisions among the electrons. So their velocity will continuously change. The instantaneous velocity will continuously change. So drift speed means the average speed. Say for example, if you think about a wire, so when an electron moves through the wire, it will move from here, then here, it have a collision, then it will move from here, like that. It will move on different zigzag paths. Okay, that's the way the electron will move due to collision with the atomic planes and also due to collision with other electrons. So the drift speed means the average speed. The length of the wire, if I say L, and the time taken by the electron, by an electron to travel from here to here is T. The drift speed, normally denoted by V. Some books they use VD, but in your syllabus they use just V. That is given by L over T. So what is drift speed means? The average speed. Average speed. Actually, you know, those electrons are dragged by the electric field when you connect a wire to a power supply. Electric field will be developed inside the wire. So that electric field drifts them, pull them, right? So anyway, we don't need electric field in unit 2, that is in unit 4 for Edexcel students. Anyway, drift speed means average speed because they don't travel on straight line. Due to continuous collision, their instantaneous velocity will continuously change. Okay, so you should know the meaning of charge carrier density and the drift speed. Drift speed is denoted by V. Normally we use the unit meter per second, the unit of drift speed. Okay, so next thing is transport equation, an equation that relates current flow, charge carrier density, area of cross section of a wire, and the drift speed. Okay, so here we assume the wire is a model we use. You know, in physics we mostly use a model, right? Different concepts, we use different models. So here we use the wire is completely filled with free electrons, right? That's the way we take assumption and derive this equation. So imagine like through a pipe or hose pipe, water flows like that. Electrons are flowing through the wire, right? We assume like that. So the charge carrier density of this particular material, you know, charge carrier density is constant for a particular type of material, right? For a particular type of material, charge carrier density is constant regardless of the shape of the material. Charge carrier density is constant for a particular type of material. So okay, we'll assume the charge carrier density of this material of wire is N. So the area of cross section of the wire is A. And the drift speed of the electrons, that's average speed of the electrons, is V. All the electrons will have the same average speed, same drift speed for all the electrons, right? So if you think about that way, during unit time, during 1 second, the length of electron column which comes out through the wire. Imagine like through a pipe, water is flowing. Imagine through a pipe, water is flowing. If you think like that, the amount of electrons, the total amount of electrons, total number of electrons coming out through the wire, or total length of the electron column. Think about the length of the electron column which is coming out through the wire during unit second is V. because drift speed is v. Compare it with a hose pipe through that water is flowing. Unit 1 in Edexcel, you learned that. If the speed of the water through the wire is, for example, 2 meter per second, during 1 second, the length of the water column coming out through the pipe will be equal to 2 meter. Same way, here we take the drift speed of the electrons is v. So during 1 second, the length of the electron column comes out through the wire will be v. Okay, so the area of cross section here is A. So what volume of electron column coming out, through the wire will be equal to length of the electron column into the area of cross section. That is the total volume of electron column coming out through the wire per second. But in 1 unit volume, the number of electrons is n. That is the charge carrier density. Number of electrons per unit volume is the charge carrier density, that is n. So what's the number of electrons coming out through the wire per second? Number of electrons passing through the wire during 1 second equal to volume of the electrons column coming out through the wire into number of electrons per unit volume, that is the charge carrier density. Okay, so what is the amount of charge flowing through the wire per second? Charge flown through the wire per second during unit second. This is the number of electrons flowing through the wire during unit time. So multiply this by charge of an electron. So that is VAN into charge of an electron, E. So charge flown through the wire during unit time, during 1 second, is the current flow. So this is the current flow. So current is given by VANE. Normally we write NAEV. So this is the second equation related to electricity. Okay, I'll quickly tell again. We assume the wire is completely filled with free electrons and the drift speed is V. The charge carrier density of the material of the wire is M. So during unit time, the electron column comes out through the wire during unit time will be, the length of the electron column coming out through the wire will be V, compared with the water flowing through a pipe. So volume of the electron column coming out through the wire per second, or volume of electron column flown through the wire during unit time, 1 second, is V into area of cross section. Then I can say number of electrons flown through the wire during unit time is equal to V into A, that's the volume flown, into number of electrons per unit volume is N, that is the charge carrier density. So if you multiply by that, you will get the number of electrons flown through the wire during unit time. So the amount of charge flown through the wire during unit time is, multiply this by charge of an electron, which is E. But we know that charge flown through the wire per unit time is called current flow. So current is equal to VANE, that is NAEV. So far we learned in electricity 2 equations. The first equation, Q equal IT. The second equation, I equal NAEV. So here when we are using this equation, N must be in per meter cube, area must be in meters, charge of an electron must be in coulomb, and the drift speed must be in meter per second. Then you will get current in ampere. Okay, so that's the way the units must be used. Okay, so we'll do a few questions based on these 2 equations. I uploaded the worksheet with short notes. You can download it from the description part of the video. Okay, I uploaded the basic short notes and these questions, so you can download it from the description of this video. Okay, we'll do those questions now. Okay, the first question, sorry, actually this is the second question compared to the first one I already did based on Q equal IT. So this question, actually the questions are uploaded in the Google Drive. You can download it from the description of this video, right? So I'm not writing the question. I just read the questions. Questions are there. You can download them from the description of this video, right? Okay. So this question says it's a semiconductor strip. The width of the strip is 6 millimeter and the thickness is 0.5 millimeter, and it's made of a semiconductor, and the charge carrier density of the material of this semiconductor is 7 into 10 to the power 23 per meter cube. So there's a current flow through this strip that is 8 milliampere. The question is, first part, find the drift speed of the electrons, of these electrons. So simple question. So first part I can use I equal NA So current is given 8 milliampere. So 8 into 10 to the power minus 3 equal. Charge carrier density is 7 into 10 to the power 23. Area of cross section, this is the area. So here area of cross section means that area which is perpendicular to the direction of current flow. So the current is flowing through this way, so it's going to come out through this way. So this is the area, not the whole area, the area which is perpendicular to the direction of current flow. So current is flowing this way, so this is the area that is right angle or perpendicular to the direction of current flow. So the area must be 6 millimeter into 0.5 millimeter. So we should convert to meters. So that will be 6 into 10 to the power minus 3 into 0.5 into 10 to the power minus 3 times charge of an electron 1.6 10 to the power minus 19 into V. Find the V. Lot of numbers are there, but carefully solve it. You will get 0.023 meter per second. So you can see the drift speed are very small. Drift speed is very small, right? So 0.023 meter per second. That's the answer for the first part. Okay, second part, I'll read the question. An approximate value for the drift speed in copper wire of the same dimension. So that means you have another wire, another strip of wire that's made of copper, right? So copper will have different charge carrier density compared to semiconductor. Same dimension, same width, same thickness, everything same dimension, but made of copper, right? An approximate value for the drift speed in copper wire of the same dimensions and carrying the same current, so that also carrying 8 milliampere, would be about 10 to the power minus 6 meter per second. So for that strip of wire, the drift speed is 10 to the power minus 6 meter per second is given there, the question, right? Find the charge carrier density of the copper. Find the charge carrier density of the copper. So we need to find the charge carrier density. So in second part, what are the given quantities? They are saying same dimension, same current. Charge carrier density is the question for the second part, right? And the drift speed is given 10 to the power minus 6. So use the equation again for the copper strip. I equal Na EV. Same current, so 8 into 10 to the power minus 3. N I need to find. Area of cross section same because same dimension they are saying. So 0.5 into 10 to the power minus 3 into 6 into 10 to the power minus 3 into 1.6 10 to the power minus 19 charge of an electron. Drift speed is given in the second part, that is 10 to the power minus 6. Solve it and find the charge carrier density. You will get 1.66 10 to the power 28 per meter cube. You know copper is a conductor, so charge carrier density is more than semiconductor, which is 10 to the power 23. This is 10 to the power 28. Okay, so the second question, you can download the questions from the description of this video. So I'm not writing it, I'll read the question. The second question, Io. So that's the name of a moon, right? So Io is one of the Jupiter's moon. Io is one of the Jupiter's moons. Some electrons released from the volcanic surface of Io has an average velocity of 2.9 into 10 to the power 7, right? 2.9 into 10 to the power 7 meter per second. So the electrons are flowing from, this is Io, one of the moons of the Jupiter. This is the Jupiter. So the electrons are flowing from Io to Jupiter at this average velocity. And the distance between the Jupiter and Io, so the distance between the Jupiter and Io, that is 4.2 10 to the power 5 kilometers. So first part, find the time taken for these electrons to reach the Jupiter. So find the time taken for these electrons to reach the Jupiter. So that is nothing actually. We can find the speed equal distance over time we can use. So we know the average speed is given 2.9 10 to the power 7. Distance 4.2 10 to the power 5 kilometer. Convert to meter. 4.2 10 to the power 5 into 10 to the power 3 divided by t. So find the time. So the time will be 14.48 seconds. So that's the average time taken for the electrons to reach Jupiter from Io, the moon. Second part, in this way, a current of 3 into 10 to the power 6 ampere created. So, I told that whenever there's a flow of charge, even the charge need not to be an electron, any charge, the rate of flow of charge causes current, right? So, they are saying there's a current flow 3 into 10 to the power 6 amperes of current between Io and Jupiter. Calculate the number of electrons that arrive at Jupiter every second. So the current flow is given, right? Second part, the current flow is given, that is 3 into 10 to the power 6 ampere. That means I can say this much of 3 into 10 to the power 6 coulomb per second. How many electrons arrive Jupiter every second? So every second, 3 into 10 to the power 6 coulomb charge is reaching the Jupiter every second. So how many electrons are reaching? So it's an old past paper question from Edexcel. So the charge of an electron is given in the data sheet. We know charge of an electron is 1.6 10 to the power minus 19. So how many electrons are reaching Jupiter every second means I can find by dividing this 3 into 10 to the power 6 divided by charge of an electron gives the number of electrons reaching the Jupiter every second. That will be 1.875 10 to the power 25. That's the number of electrons reaching the Jupiter every second. Okay, so that's the end of first lesson. So in first lesson, we learned two equations, Q equal IT and I equal NAED. We'll use these equations later in the second, third, and the following other lessons also. Okay, right, bye.